Alright, so our last pattern is going to be a little different. The last two were differences, subtractions, but this one's actually a sum. And so in this case, we have a binomial that's an addition, and then we have a couple of terms that can be written as something cubed. Again, I'm going to approach this, since we haven't seen this pattern, let's approach it with multiplication, right? And then once we see the multiplication, we know we can just reverse ourselves to do the factorization. Alright, so it turns out that the pattern for the sum of cubes is very similar to the pattern of the difference of squares. Alright, it begins with a binomial, but this time, since we're adding, the binomial is a plus b. And then just like the last one, we're going to take the first term, we're going to square it. We're going to take the last term, we're going to square it. We're going to take the two items and multiply them. But what's different is this will now be a subtraction, and that remains addition. So the difference of cubes pattern, if you want to bring it out, very similar, right? But this was a difference, and that was a sum. The sum of cubes, same pattern with the terms, but since we're adding the binomial's addition, and that sign's opposite, all right, subtraction, and then that's always positive. And so let's go ahead and do the multiplication and see that if we take this type of binomial and multiply it to this type of trinomial, we would get that pattern. So again, we'll distribute the a. A times a squared gives us an a cubed. A positive times a negative is a negative, and we get a squared b. A positive times a positive is a positive, and we get ab squared. So we just distributed the a. Now we do the b, and when I distribute that here, we get a positive a squared b. A positive times a negative is a negative, ab squared. And then a positive times a positive gives us a positive b cubed. And just like that last pattern, because of this little nuance in the signs, notice that there's an a squared b and there's an a squared b. But we're subtracting or adding, so those two terms cancel each other out. Here's a positive ab squared, and we're subtracting ab squared. So those two terms cancel out. And so we're left with a cubed minus b cubed. So there's the multiplication, and of course what does factorization do? It reverses that. So if we have a sum of cubes, it breaks up into a product of that type of binomial times that type of trinomial. So let's just practice this. Let's invent one of these. So let's say that I have 2x, and let's go with plus 3. Right, and so the trinomial would be the first term squared, the last term squared, and their product, 2x times 3 in the middle, minus plus. And so there's basically an example of me using that. So these two terms here determine the terms in the trinomial. And of course, if I multiply them together, right, what I'm supposed to get, right, if it follows the pattern, is 2x cubed plus 3 cubed. So I'm expecting 8x cubed plus 27 out of all this. So let's multiply it to see if my expectations ring true. So if I multiply by distributing the 2x, I get an 8x cubed, I get a negative 12x squared, and I get a positive 18x. Now distributing the 3, I get a positive 12x squared, a minus 18x, and then a plus 27. And terms cancel out, and we're left exactly what I thought would happen. Alright, so it's a shortcut basically. So there you go. So we now have another formula. Now let's go use it to factor. And so in our first example, I do have a binomial. It is a sum, and there seems to be a cube. So is this a sum of cubes? Right? And oops, let me put a 1 there. Alright, and so x cubed obviously is cubed, and then 125, that's 5 cubed. So this does fit the pattern. It is the sum of cubes. So here's your a, and there's your b. Let me rewrite the formula down here so we can just literally plug in my a's and b's. So this becomes x plus 5. We're going to square the x. We're going to square the 5, giving us 25. And then in the middle, we're going to subtract the product. So 5 times x. And there is your factorization. Of course, you can check that by remultiplying it to see that it's true. very similar pattern to the difference of cubes. All right, and so the next one, I have a binomial. It is a sum, and there's a cube. So is this truly the difference of cubes pattern? So if we take a look at the beginning term, that is 3x to the third power. And then 8, well, that's 2 to the third power. So this does in fact fit the sum of two cubes. Here's your A and there's your B. So writing my formula down, all we need to do is just plug in information to factor. So A is 3x, B is 2, and then we're going to take whatever A is and square it. So 3x squared would be 9x squared. We're going to take whatever B is and we're going to square it. So that gives us a 4. And then we're going to subtract their product. So 3x times 2 is 6x. And there's your factorization. So factoring by using the sum of cubes pattern. Figure out what A and B are, plug them into the formula. That's all you got to do. All right. Moving forward, again, I have another binomial. It is a sum, and I see a cube. So does it fit the pattern? Well, the first term is 5x being cubed, and then 1 is whatever I want, right? To any power is 1. So we'll put it to the cube power. It fits. So here's A, here's B, and we just plug things in, right? So here's the formula. We have 5x plus 1. We're going to take the 5x and we're going to square it. That gives us 25x squared. We're going to take the 1 and we're going to square it. It gives us 1. And then we're going to subtract the product. Well, 5x times 1 is 5x. And so there's that one. Again, you can check by multiplying it together. And then last not but least, we have a sum. It looks like some cubes. We just need to make sure it fits the pattern. And so that first one is the term 3x being cubed, and the second one is 2y being cubed. And so it does fit the pattern. Here's your A, here's your B. I will rewrite the pattern here since there's a lot going on. And then so we'll replace A with 3x and replace the B with 2y. And then we square whatever A is. So 3x squared is 9x squared. We take whatever B is and square it. So there's a 4y squared. We subtract their product. So 3x times 2y is 6xy. And there's your factorization. All right, so sum of cubes. So that's about it. We actually have a complete flow chart. We'll be taking a look at that momentarily when we move into 5.6. But everything's accounted for now that we know all our patterns. So we know how to do things with the GCF. We know how to do things with patterns. We know how to handle trinomials. We know how to handle things with 4 or more terms. So we've got a lot on our docket. But truly, to wrap up 5.4 and 5.5, what we're going to do is just, I'm going to give you a bunch of examples, and we'll see how it works. But there's your sum of cubes. And let's go do more.